Hello everybody. I have had the pleasure in several videos now of showing you various pieces of vintage broadcast video equipment. And my dream is to eventually have shown you everything that you need to know to have your own TV station, or at least a TV station 30 years ago. Well, in today's video, we are adding another piece to that puzzle. I am gonna show you two pieces of equipment here made by Leitch Video in the mid-1990s. We've looked at other equipment made by Leitch in the past, notably my Leitch CSD 5300 clock system driver, a real-time clock and timecode generator that has a built-in modem that, as of this taping, is still connected to the phone line, and you can still call it. I've gotten over 100 calls to this thing, and if you want to know how to do that, you can watch the video on it and get the phone numbers for it and how to communicate with it. Well, Leitch also made these two pieces of equipment that we're going to look at today. This upper one is a Leitch SPG-2602N sync pulse generator. The lower one is a Leitch FR-2602 multifunction frame. These are two identical pieces of equipment. These do the same base functions. The difference between them and the reason that they've got different model numbers is just that they would have originally come with a different base set of cards. These are the same thing. They are frames that can take cards. You can put many cards in them, and the cards do various things. And so one of these frames can have a set of cards in it to perform many various useful functions that you would have in your television station of 30 years ago. And the SPG-2602 would have come with a specific set of included base configuration cards than the FR-2602. But other than that, these are identical devices. These came from the TV station, of course, and this unit was actually in use at the TV station until about 4 or 5 years ago. When I started as a volunteer in 2020, this guy was still in use. Of course, back then we still had a largely standard definition workflow. We were shooting high definition footage by that point. We had been for a few years by that point, but our broadcast was still entirely standard definition. We still had an analog transmitter. We were one of the last TV stations in Canada to be broadcasting an analog video signal, and I'm glad that I got to be able to witness that before we upgraded to high definition, and I'm also glad to have been able to help make that change to high definition. So once we upgraded to a completely digital high definition workflow, this guy got retired. I brought it home, and then I found this guy in our storage room. We had it just as a spare. It was never put into use that I can see at our station. These, of course, came from another broadcaster, and they would have been given to us many years after, once they were retired from their original broadcaster. So these are here with me now. They are here to stay, and these are really fun. These perform a lot of cool functions, and I'm really excited to show you today all the things that these can do. Especially because this video is going to be one of the only, if not the only, modern source of information on these things on the internet. There is little to no information about these. Pretty much the only information you can find about these is whatever you can grab from Leitch's website using the Internet Archive's Wayback Machine. So I'm actually not going to be able to properly explain and demonstrate everything about these today because I cannot find documentation at all. It just doesn't exist for these, which is too bad. Leitch got passed from company to company to company. In the early 2000s, Leitch was bought by Harris Corporation, the same company that bought Inscriber, the character generator manufacturer. And then Harris Corporation later merged with another company, and then that company got split into two different companies, and it's just kind of a mess. But what it all ended up doing is Leitch's assets passed from company to company to company, and now today they're owned by whatever assets are left are owned by a company called Imagine Communications. And if anybody has any documentation about these, it's going to be those guys. And I do intend to reach out to them at some point. I should do that soon and see if they have anything they can send me, manuals, whatever, about these things so that I can become better knowledgeable about them. But I'm going to be able to largely demonstrate most of their functionality to you today. And I'm really excited to do that. These do really neat things that are fun and useful to have if you're a vintage broadcast television enthusiast like I am. So how I'm going to do this is I'm going to start, like I said, these things do the same thing. It's just they would have originally come with a slightly different set of base cards. Cards were possibly added to each of these later. There are different sets of cards in both of these. I'm going to start by showing you just this guy. It has fewer cards in it, and it has almost completely what I believe to be the base configuration of what this would have done. There's only one card in it that I think might have been added afterwards. So it's a good representation of the basic functionality that you would have purchased and installed one of these things for. So we'll start with this guy. So the Leitch SPG-2602N was designed to provide two basic functions. It provides genlock and it provides test patterns. Now, starting with genlock, you guys know what genlock is. We learned about it in my two-part video series of the Sony DFS 700 video switcher from 2000. Genlock was and still is today a crucial component of every television station. Genlock is a synchronization signal that you feed into all of your broadcast video equipment. Cameras, VTRs, your transmitter, your video monitors, your character generator, everything. It's just a basic, simple signal that is very well timed, and the purpose is just to make all of your equipment synchronize itself to that signal. And when I say synchronize itself, I'm talking anything that outputs a video signal, like a video monitor, a television set, a VTR that's playing back a tape, so that it draws its picture line by line, field by field, frame by frame, in time with everything. And this is necessary because when, for example, with a video switcher, when you're switching between multiple input sources, like 3 cameras, say, while you're taping a studio show, you need all those cameras to be producing their images at the exact same time to the line, so that when you switch from one camera to the other, you don't lose synchronization because the 2 cameras that you're switching between are at different points of whatever frame they're drawing. Everything's in time so that every switch is clean. Likewise, if you're switching to a VTR that's playing a tape, it's outputting the signal from the tape at perfect time with those cameras and everything else. If you have something that's not genlocked to the rest of your transmission, you get big problems. You get loss of sync. Your picture can completely blank out when you switch to that input source, or it also might not be able to synchronize to that input source at all, and the picture just rolls really quickly, and it just doesn't work. Genlock is a crucial component of every television station. In the old days of television, when everything was analog and standard definition, a genlock signal was actually a very basic signal. It was just a black composite video signal. And actually another name for a genlock signal was blackburst, because the signal is just black composite video plus NTSC color burst signal. I'm talking everything in NTSC terms here because I'm in North America. But yeah, it was just a black video signal that also included the NTSC color burst. So basically just a black composite video signal. Genlock today is called tri-sync, tri-level sync, because it's a waveform that has like 3 different voltage levels that it goes to. I'm not sure about that, but it's called tri-sync today. That's the kind of genlock that we use today in the digital high definition world. But back in this day, it was black burst. So one of the core functions this provides is it's a black burst generator. It's got at least one card in it. It can actually be multiple cards that has multiple outputs on it so that you can run black burst to all of your equipment. This would be the source of all synchronization in your television station. You would run a black burst output from this thing into your video switcher, and then you might loop it into your VTRs, and then you might loop it into your waveform monitors, and then loop it into your video routers, and then loop it into your transmitter, and every single piece of video equipment at your station is all synchronized to this unit. This is something that would run 24/7. And anything in your station that needed genlock, it would always have genlock, and it would be genlock to everything else at the station. Now, most video switchers do themselves provide genlock, and you certainly can use your video switcher as a genlock source for other equipment. In fact, I've done that with the DFS 700. But that's not really that practical to do at a TV station, because a video switcher is not something that is gonna stay powered on 24/7. At least some stations don't do that. And oftentimes it just might not be practical to use your video switcher as a genlock source. In the TV station of 30 years ago, your video switcher is obviously going to be in your control room, but then quite far away in the station, you're going to have your master control facility where you've got a stack of VCRs all queued up to play tapes all day long that play your shows and then your commercials and then your station ID. And of course, all those VTRs need to be genlocked with each other and your transmitter, and if you're doing a live show, then your master control facility might be employed to play commercials, and then your facility has to be also genlocked back to your video switcher. And so it just might not be reliable or practical to use your video switcher as the genlock source. And that's where something like this comes in. This is a piece of equipment that's designed to run 24/7, 365 for years or decades. And it can be strategically placed anywhere in your facility and then have cables run wherever you need to. And so you can genlock your video switcher to this, and then the black burst outputs on your video switcher are genlocked to whatever's going in the black burst input, and then you can connect your camera CCUs and your control room VTR to your video switcher. Video switchers provide black burst outputs mostly as a convenience, and you'll normally just use it for the immediate equipment in your control room so that you're not having to run multiple lines back from your master sync generator to your control room. And your master sync generator is going to be this guy. So that is one of the core functions that this unit is going to provide. The other core function that this provides is it'll output test patterns. And a device that can output test patterns is a very important thing to have in your TV station for multiple reasons. In your TV station of 30 years ago, you probably go off air at night. And if you're my age or older, you're perhaps lucky enough to remember the time when TV stations went off the air. What we do today, you tune into any TV station in the middle of the night and it's probably playing some sort of overnight shopping channel or maybe a community billboard. And it didn't always used to be that way. There was once a time when television stations signed off at like 11 p.m. or 12 a.m. or whatever. They said good night to the viewer. Here's our phone numbers if you ever want to call us with viewer feedback. Thanks so much for watching. Have a pleasant night and a pleasant morning. And then it just makes a hard switch to color bars and a 1 kilohertz tone. And that would have been generated by one of these as well. If you lived in Canada and tuned into a TV station at night that was off the air, it's actually highly likely that the color bars and the tone you were watching and listening to was generated by one of these very frames. But that's just one of many uses that a test pattern like color bars can be used for. And this can output multiple types of test patterns, which we will see later. It does SMPTE color bars, EIA color bars, normal color bars that just extend the full frame of the TV picture, and other kinds of test patterns that are used to verify the functionality of equipment like waveform monitors. It can verify the health of equipment like VTRs and stuff like that, because of course a piece of equipment like this will have been very tightly calibrated from the factory. I'll explain later why color bars, SMPTE color bars in particular, are so important, but they are extremely important. They serve many important functions for the verification of the functionality and quality and calibration of all the other equipment in your station. And Leitch would have very tightly calibrated this at the factory so that the color bars that this thing outputs are exactly what they're supposed to be. The exact chroma phase, because we're in NTSC land, and it's a miracle that NTSC even works at all because it's such a kludge compared to the PAL color television system. So things like the chroma phase and the chroma intensity and the luma intensity all have to be exact. The timing of the signal, the vertical and horizontal timing have to be exact. And you could be assured that a piece of equipment like this would be dialed in exactly perfectly. And in fact, Leitch probably encouraged you back in the day to send one of these in every 5 years or so just to get recalibrated to make sure it remained tight. And you could use one of these to compare against your VTRs, your waveform monitors, your character generator, and just make sure that everything else in your station was still working properly. So, but color bars is just one of the many patterns that this thing can actually output, which is pretty cool. And in addition to a test pattern like color bars, this actually has an extremely rudimentary character generator in it for the sole purpose of putting basically just a call sign at the bottom or in the bottom right corner of a set of color bars, which, going back in the day when stations went off the air, you know, if you ever tuned into a station and it you know, in the middle of the night, and you'd have the color bars and the 1 kilohertz tone, but then in the lower right corner there would also be white text that said, you know, WAGM Presque Isle or whatever. And that text would also be generated by a piece of equipment like this, and this particular frame has the card to be able to do that, and we will demonstrate it as well. It's all very cool, it's all very fun, and it's all very useful. And I don't just mean useful 30 years ago. I mean, I actually today make genuine use of this thing. Because I am in a now 5-year-long project of digitizing hundreds of videotapes that we have at the TV station. Videotapes containing genuinely historical content that needs to be saved. My goal is to have it all digitized, and then we can give the tapes to the provincial archives where they'll hopefully spend the rest of eternity, and then we'll have our own digital copy of all those tapes for whatever we want to do with it. But once in a great while, I come across a tape that was incorrectly recorded. It was recorded on a VTR that was just either out of adjustment, or the built-in proc amp was misadjusted or whatever. And common practice, luckily, for TV stations is anytime you tape a show in the studio, the first thing you lay on the tape is color bars. You would switch the input of your VTR to the color bar generator of a frame like this one and just record, 30 seconds or a minute of color bars. And then that way, when you go back to play the tape in the future and the VTR plays back those color bars, you can very quickly verify that whatever was recorded is going to look correct in the broadcast. If you look at your waveform monitor and discover that the color bars are just not quite the right brightness or not quite the right color, you can very quickly correct it using your proc amp, your processing amplifier, to adjust the chroma phase or the video level or whatever, to make sure that it looks right on the television screen of your viewers. And so that's another really important way that you can use these. And once in a while, I run across a tape that it was recorded on a VCR that was just, either malfunctioning or just misadjusted, or someone accidentally bumped a knob on the proc amp or whatever. And I just very quickly compare the color bars recorded on the tape to the color bars output by this thing, notice that there's indeed a difference, and then I can make adjustments on the proc amp built into the VTR. I'm talking about Betacam SP tapes here. And just adjust the proc amp really quickly to match, so that the digitized video file that I'm recording looks as it was originally intended to look. So I actually do make actual use of this. It's not just a toy. It's mostly a toy though, but that's all right. So, without further ado, let's open this thing up. Pull this little lock here, and the front comes out like that. Some stuff that wasn't supposed to fall out falls out. That should be taped right about there. So you can see there's 5 cards in this thing, and there's the power supply. And every card and the power supply have their own models. So the power supply in this is called the 1302 PS. Most of these cards are going to have models that start in either 1302 or 2602, and that's because this is actually the big boy version of the sync pulse generator. Leitch made another model called the SPG-2602N. It's the same thing, but instead of taking, I think it's 9 cards that this thing can take, 1, 2, 3, 4, 5, 6, 7, 8, 9. The SPG 1302 only takes 4 cards, and it's half the height as a result. So if you only needed 4 cards, you would buy that one. If you needed more functionality or anticipated needing to upgrade and install more functionality in the future, you could buy the bigger unit, which is this. So we've got 5 cards installed. The cards came with these little plates here that give you basic information on how to use the cards, because you can see the cards have little dials on them. They've got dip switches for all the different things that you might need to adjust. Some of these, like on the card that produces color bars, one of these rotary switches is gonna switch between the various test patterns that are available, and there's gonna be more controls on each card to adjust stuff like the video level and stuff like that. So that's all I'm going to show you for now. We will take out each of these cards in a few moments, but what I want to do first is flip this thing around the back, and so we can see the connections on the back, and then I will tell you what each of these cards exactly are. And if we look over here, you might be able to see a couple of stickers revealing the original owner of this piece of equipment back in the day. This was made in, I always thought 1994, because the majority of the, I think all of the components across these cards have date codes of either 1993 or 1994. But the serial number on this actually begins with 95, and presumably Leitch was still using the same serial number format, which means this was actually made in 1995. So let me flip this thing around. We'll look at the back side of the cards, and I will explain to you what each card does. Alright, starting first, we're going to start on the right here. The first card is the 1302 GL. This is the genlock card. This has the oscillator in it that actually generates the clock signal that everything else uses. And so this card is actually imperative. None of the other cards in the system will function without this card. This card is the basis for everything. It has the actual oscillator that generates the timing to create the sync signal and all the other signals. It's got a 9-pin D-sub port on it. I doubt that's serial. That's probably just a simple signaling port, and I have no idea what you would use it for. And you can see, of course, everything on here is BNCs, of course, and this has two BNCs. One's just a loop through of the other, which is why it's got this terminator on it. You always want to terminate your unused loop through outputs. But this is just a genlock input. So if you had more than one of these things and you wanted to genlock one to the other, you can do that. One might be your master genlock source, and then the other just a slave source that's used in a particular part of your facility. So you would run a blackburst output from your master unit to the genlock input of your slave unit, and then they're synchronized to each other. So that's all that's for. You don't need to use these. So that's the first card. The second card is the 1302 PG. This is a sync signal output, but it splits the sync signal into all of its base components. So a blackburst signal, as simple of a signal as it is, it really consists of many different components all working together to create a black composite video signal. And this card splits all those components into separate components so that if you have a piece of equipment that takes this form of genlock, it can do it. Now, I only know one type of thing that actually requires this type of genlock, and that's quadruplex VTRs. Quadruplex was the first practical videotape format, at least here in North America. It was developed by Ampex, introduced in the 1950s, and it remained in use pretty much until the end of the 70s, where by then it was replaced by either Type-C videotape for larger stations or U-matic videotape for smaller stations. And quadruplex was just huge in general. It was big, 2-inch wide magnetic tape on big open reels, and the VTRs themselves, at least the early ones, they were 7-foot high, gigantic machines. And I think some TV stations must have kept straggling along and using them into the 1980s, because I've seen videos on YouTube like home camcorder footage that someone working in master control at a TV station at night recorded of them threading up quadruplex videotape. So obviously there were some stragglers into the 80s still using it, which isn't a surprise because the machines were tens of thousands or sometimes even hundreds of thousands of dollars for the VTRs. But yeah, that's the only thing that I know of that used this kind of sync was quadruplex videotape. There could be more. But otherwise, you wouldn't really ever use these. What you would use is standard blackburst, which is what the third card over here, the 1302 BT, provides. It's got two blackburst outputs. And you can see there's also this terminal block here. What is that? Well, that is to output a tone. Like I said earlier, if you're my age or older and you were lucky enough to live back in the days when television stations went off the air at night, you'd see color bars, but then also hear a tone. Sometimes it was a 1 kilohertz tone. Other times it would be a 400 hertz tone, which I actually prefer. It's just more nostalgic to me. and a little easier on the ears in my opinion. And so this card actually generates a tone, and it can be configured, at least on another card it can be configured. I'm not sure about this card. This card it might just be 1 kilohertz, but on another card, this card that we're going to get to, it can be configured to be either 1 kilohertz or 400 hertz. But that's what this is for. You get your genlock and you get your test tone. So not only can you sync your devices, but this tone has also been calibrated to probably like a line level signal. So you can put that line level tone into your VTRs and all your other equipment and calibrate the input levels so everything's the same volume and you don't accidentally have something going to air that's quieter or louder than it should be. So that's the two functions that this card provides. This card is when we start getting fun. This is the 2602TG. This is the test signal generator. It's got two outputs. They output the same thing. It's got a 9-pin, what they're calling a remote control port. So this is probably just a simple signaling port that can change functions on the card that you can also do from the switches that are on the front of the card. And so that'll be either color bars or some of the other types of signals that we'll look at. But that's what this card provides. It's got two outputs for it. And then the fanciest card and the most fun card on this machine is this card, the 1302BB. This card provides multiple functions. It provides two black burst outputs and two test pattern outputs. And once again, there's multiple test patterns that you can choose from. It's also got a audio tone output, and that can be configured to be either 1 kilohertz or 400 hertz. And it's got an actual serial port on it, and you would use this serial port. I'm not sure if you can use it just from a terminal, like a VT100 compatible terminal, or if there's actual software that you could use, but you could use that to work the very rudimentary character generator built onto this card to type out text that gets displayed on top of the test pattern. Now, luckily, you can also print out that text and configure that text from the controls on the front of the card, which I have done. So when we demonstrate this card, you will see I've got my color bar signals with let's call it a call sign in the lower right corner, just like you would have seen in the old days. And that is the 5 cards on this rig. And you can see that each card, the card and the ports on the back of the card are actually two separate components. We can remove the cards, but these ports will stay here. They're two separate pieces, and when you got a card for this thing, it came as the card itself, and then this little block with all the jacks and ports, which you would then screw in to the unit. And that's actually how multifunction frames still are today. I guess it's just the easiest way to do it. The cards all come separate with the card itself and then the ports that provide the interfaces on the card. And so that means you got to be careful and not swap cards around accidentally. If you do swap cards, you've got to swap the back parts as well. I don't know if it would damage anything if you had the cards swapped and the cards plugged into the wrong back planes. But at the very least, nothing would work right. So there you go, and we've got an IEC jack and a remote port, which I have no idea what you would use for. Maybe it just controls the power supply, like you can turn the power supply on and off remotely. No idea. And if you need to remove the power supply, which is also a plug-in module, you would take out that screw right there, and then the power supply slides out from the front. And I forgot to mention, on both of these, I actually had to make repairs. Both of these had bad power supplies. Just like with the Leitch CSD-5300, Leitch just for some reason just didn't use good capacitors in any of their 90s equipment. So just like the CSD-5300, these things just did not turn on at all when I first got them. Like I said, I took this one out of service at the station in, I think it was last year, 2024, was when this thing finally got unplugged. It wasn't connected to anything anymore by 2024. It hadn't been for a few years, but it was still plugged into power. Nobody ever unplugged it. And so this was still working fine when I unplugged it for the first time in years in 2024, but just mere weeks, if not days after I got this thing home, it suddenly stopped turning on. Just the act of the power supply being de-energized for the first time in years, if not decades, caused all the capacitors to just immediately fail. And so I had to open up the power supply, replace the capacitors, I think 10 or 15 electrolytic capacitors. Super easy to do, single layer PCB, very easy to do. So if you get one of these and it just doesn't power on or do anything, replace the power supply capacitors. Actually, I would implore you, even if it does function, to replace them anyway, because you're going to have to do it. And I got with these things not only a power supply in each of them that had to be recapped, but I got a spare power supply which also didn't work, and I actually couldn't get it fixed. I recapped it and it stayed dead. So something else failed, a semiconductor or something. And I did some troubleshooting and I wasn't able to figure out what part was wrong with it. So I ended up just recycling it, which is too bad. Part of me wishes I had dug in a bit further. Anyway, that's another reason to kind of preemptively recap the power supply if you have one of these, because bad caps could cause something else to fail as well. But yeah, remove that screw, power supply comes out, power supply comes apart super easily, and it's really easy to recap, so just do it. So I'll flip this thing back around again, and then we'll pull out each card so you can take a look at them. So you can see the power supply has this little switch on it. Actually, this is a dual function, or really it's a single function. I was about to say it's a dual function because it's not only a switch, I believe it pulls out to turn off and pushes in to turn on, but it's also a circuit breaker. If one of these cards, or the quantity of cards, overloads the power supply, this breaker will actually trip and the switch will pop out and the unit will power down. But really, this isn't meant to be a switch, although maybe it was, because you can manually pull it in and out. Because this isn't something you would ever really turn off. This is really primarily meant to be a circuit breaker. So let's take out the first card. We'll start with the sync generator card itself, the card that generates the sync signal that all these other cards depend on to function properly. It just slides out like that. And here's what the cards look like. And the primary component here is this oscillator, quartz oscillator. We get a little potentiometer to adjust the frequency, but then we get these two switches to set coarse and medium. And I haven't a sweet clue what those would adjust. If that's the frequency adjustment, and the only thing this card generates is a clock signal, what are these generating? I don't know. I don't have documentation for this, unfortunately. You've got a little LED that lights up, I believe, if you have a black burst signal going into the genlock input on this card, and that lets you know that it has locked to that input signal. And you also have a switch to choose between whether it does lock to that input signal or if it ignores it and just uses its own sync signal generated by this quartz oscillator. We see another sticker identifying our public broadcaster that originally owned this thing. And we've got some chips that I don't know what they are. I see 1994 date codes, got some 7400 series logic. We've got a dial here to adjust the SCH, that's the subcarrier to horizontal phase, the relationship between when the horizontal interval happens and when the color burst signal happens. Those two things have to be at the right timing relationship with each other. Got that's probably an FPGA chip. And that is the multi-pin connector that interfaces with the backplane. that you can see in there. So there is that. Here's what the back side looks like. And this card generates our genlock signal. This is the most important card in the entire system. Nothing else works without it. Here's the card that takes the sync signal and splits it into its various components for whatever weird equipment, such as quadruplex videotape recorders, require it. It's got an EEPROM chip on it. Not sure why. And seeing this tells me that, because most of these cards have UV erasable EEPROMs on them, and if any of those ever go bad, I mean, these things, the documentation for these things are unobtainium, but the hardware itself isn't. You can go on eBay and sometimes find the cards or find entire frames, but they're just not cheap for some reason, just because of the nature of what they are. Sellers still think that, you know, there's a TV station out there that really needs one of these and will pay $200 for one. In my opinion, these just aren't worth that much. And hobbyists aren't really buying these either, although after this video goes out, that may change. But yeah, all goes to show, maybe I want to invest some money in a ROM reader, just so I can back up these ROMs. If something ever goes wrong, I can reload the ROMs. But here's this, and you've got the subcarrier level, pulse level, adjustments for that. T-edge, L-edge, I don't know what any of this is. Subcarrier phase. Stuff that I just don't really know about. Got some dials here. Blanking start, blanking finish. BF positive, BF position, N. Again, don't really know. But there's a date code there, 9411. And back in, this guy goes. Let's get our 1302 BT Blackburst generator. Oh, and I forgot to mention, all these cards have these little info cards on them that tell you what it is, what the controls do. So, for example, on the genlock card, we have the LED for the lock status, whether or not we want to lock it to the input signal, coarse and medium phase, fine phase, and the oscillator frequency. And then on the card that splits the signal into its many components, lines of advance, frame identification line, whatever that is, and then the width of the vertical blanking interval in lines. And then the Blackburst generator. So yes, we can switch with the dip switches on there. We can switch between 400 and 1 kilohertz tone. Whatever normal and channel B ident means, I'm not sure. Normal, line advance, normal, setup on. Setup is an NTSC specific thing where the black level can be at a certain level, or if the device incorporates setup, the black level of the signal will be slightly raised. And then the controls there are the tone level, so how loud the tone is. So you'd use an oscilloscope probably to dial it in so it's the proper line level So that's the Blackburst generator, our 2602 TG color bar generator. Here we go. We've got 3 EEPROMs on this. What kind of EEPROMs are these? 512 kilobit. And I don't know what the other ones are. And this card is probably a programmable array logic chip. We have a knob to select the various test patterns that we have access to, and we'll go through those when we power this thing on and connect a monitor to it. And then these phase controls, I originally assumed that they controlled the chroma phase, but they don't. What they actually control is the timing of the video output with respect to the internally generated genlock signal being generated by the genlock card. So turning these two dials doesn't affect anything that you can see on a video monitor as long as you're using the video monitor's own internal reference, such as a television set. But if you use a professional video monitor and plug a blackburst output into the external reference input of the monitor and then use that reference for the monitor's output, then you'll actually see the picture shift horizontally when you turn these dials. And if you turn these dials far enough, you'll either lose color eventually because the color burst signal happens before the horizontal interval occurs, or if you turn it the other way, the colors will go all crazy because the color burst signal is happening way too late into the picture. OP level, that must be the level of the audio tone output. So there's that stuff. And then the fanciest card, our color bar plus identification generator. This has got some fancier circuitry on it. It's got a Dallas soft micro. This is a microcontroller. A couple more UV erasable EEPROMs. I should really back all of these up. We've got a rotary switch to select the pattern. This is a momentary switch that's used to toggle selections in a menu that you can actually call up on this, and it's also used to set what letters are actually displayed for your station identification. Once again, we have a audio level adjustment. We've got a black level adjustment, and I don't know what this other adjustment is. It might be the chroma intensity. Another FPGA chip. Yeah. Delay bars. I'm not sure what that means. And once again, we can turn setup on or off. And if we look at the info card right here, it actually gives you a list of all the patterns that are available, including a page, a mode that you can put it in where you can program the station identification characters. So there is that card. All right, let's get to the moment that you guys have been waiting for. I'm going to dig up a video monitor. We're going to connect it to all the various outputs that this thing has, and you guys will get to see all the various things that this thing can do. I'm excited. Let's get to it. All right, well, I've got a PVM hooked up, and for our first test, I have it hooked up to a blackburst output, and this is what you see from a blackburst output. It's just a black video signal, like I said. In fact, if you didn't know any better, you might think there was no signal hooked up at all. But if I press the horizontal vertical delay on this monitor, and that's why I chose this monitor, because it has this function. You don't need a fancy video monitor to see the output from one of these. Any standard television set or VCR with a composite video input will work. But you can see the horizontal vertical delay. You can see this part right here, that is the horizontal interval, and this part right here, which is the vertical blanking interval. And if I didn't have any signal at all going into this, you wouldn't see those, because those are a part of any composite video signal. Now, I just so happen to also have the tone output from the blackburst card wired into this. So if I turn the volume up, you can hear that lovely 400 Hertz tone. So the other thing, turn off the HV delay here. So this switch on the bottom is the NTSC setup level, and I wanted to do my due diligence and do a little bit of reading between scenes on what the NTSC setup really is for. Like I said, all it does is it raises the brightness of the black level of the signal. So the luminance signal of an NTSC video signal, the luminance level, which is the brightness of the picture, is measured in IRE, whereas 0 IRE is the level of the blanking signal, so the signal that's not even part of the picture, it's just the signal that that causes the television set or monitor to go to the next field of video. And then depending on whether you have NTSC setup turned on and off, black video is also at 0 IRE, or if setup is on, the black level will be at 7.5 IRE, so just a hint above pure black. And indeed, if I turn this dip switch down, which will turn setup on, you probably won't be able to see that on the video monitor, but the picture just goes ever such a hair brighter. You will be able to see it if I turn HV delay back on and then turn setup on and off, and you can see there's setup on, and the portion of what you see right now, which is the actual video signal, gets just a hair lighter gray. And I'll turn it back off, and there it is. So all it does is it slightly raises the black level of the signal. And I did some reading, and really the only reason you would do this is just for helping to calibrate waveform monitors, and maybe vector monitors, I forget. You really only do it for testing purposes. For any normal video application, you'll have setup turned off, although apparently back in the day, some TV stations would choose to, the engineers would choose to put the NTSC setup level to air, so the signal actually going to people's television sets had that slightly raised black level. And I think it's really just, it seems to me it was just a matter of personal preference. But this thing was meant to have it calls no setup as the normal setting, so I will have no setup. So that is the black burst signal. So for my next trick, I will show you some of the signals on this second card that split a standard composite video signal into its various components. And this is where I tell you that I also currently have a black burst signal going into the reference input on this monitor. I'm just going to make sure, yes, I do have my switch set to use the external input. So you don't need that. You don't need to use a monitor that accepts an external sync signal to see the signals from this thing. But in order to show you the various components of the black burst signal that this thing lets you use individually, I have to plug in a sync signal because, of course, a black burst signal has everything in it that a monitor needs to sync to it, but when you separate it into its various parts, some of those parts do not contain what a video monitor needs to synchronize itself to the signal. The synchronization parts just aren't there. So I have an external sync signal going into this, which is just another black burst output. And I will turn HV delay on, and I will start by just poking the various parts. And you'll be able to see, well, that one doesn't really show you much. There's just a thin flickering line in the middle. There's one part that must be, yeah, that's the burst flag. So that's part of the color burst signal. So it kind of makes sense that it looks like that. There's another part. There's another part. and another, and another. There. So you don't see anything in a couple of them, but when you add all those together, you basically get a black burst signal. So for my next trick, I'm going to plug you into the color bar generator, or the test pattern generator, but it's currently set to color bars. Turn HV delay off, and there is our color bar signal. Now, this is SMPTE color bars, and allow me to take a couple of moments to tell you why SMPTE color bars are so important, because it's more than just a pretty picture. Although it is a pretty picture, it's a nice way to demonstrate TV sets and monitors. But this is actually a highly engineered signal, and all the different parts you see do various important tasks. So for example, this particular color bar pattern is called 75% color bars, because this light gray bar on the far left has a luminance level of 75 IRE. And in fact, if I were to plug this into a black and white television set, what you would see is that from left to right, the bars all get darker. Here you don't really notice brightness changes because you're mostly paying attention to the color changes. You go from gray to yellow, cyan, green, magenta, red, and blue, where the red, blue, and green bars will energize just the red, green, and blue phosphors of the TV set. But yeah, they are arranged in luminance from higher to lower. This white square down here is at 100 IRE. And when you run the color bar pattern through various equipment, you can see if that equipment is distorting the pattern in such a way because something's miscalibrated or the equipment is malfunctioning, because you know what this color bar pattern is supposed to look like on a waveform monitor. Each one of these bars has a specific luminance signal. Likewise, each one of these bars has a specific chrominance amount, the chrominance signal, the part of a video signal that provides the color information, what color and the strength of the color. And so each of these bars, it has a well-defined voltage level that the chrominance signal should be, and you can measure that on a waveform monitor as well. Now, if I hit the blue only button on this video monitor to go into blue only mode, so it's only showing the blue component of the video signal now, you can see that the bars alternate white, black, white, black, white, black, white. And this way you can see if the equipment is changing the phase, the chroma phase or the tint of the signal at all. Because if the chroma phase was off, this alternating white, black, white would be uneven. So if I turn the chroma phase dial on this monitor to simulate a maladjusted video monitor or a maladjusted VTR, or could be a maladjusted or malfunctioning transmitter or anything, you can see we no longer have this even white, black, white going on. Turn it the other way, same deal. And actually, if I turn the chroma level down all the way, so it actually is a black and white signal, you can see how the luminance, the bars are arranged in luminance from brightest to darkest. What this little thin middle part is, you also use that with the blue only mode, and on a properly adjusted video monitor or TV set, in the blue only mode, the main bars combined with the middle section should appear as one long solid bar if your color controls are set correctly. And so this actually reveals to me that this monitor is not quite dialed in correctly, and actually is just as likely that the color bars themselves coming out of this card just aren't adjusted very well. Everything shifts with time. That's just the issue with analog electronics. But if I turn my chroma level down all the way to basically make a grayscale image, you can see what that looks like. If I turn my chroma way up, it looks like that. And then my chroma phase, of course, does that. And so it looks like I should turn my chroma level up a little bit. And then maybe adjust my chroma phase just a hair. Now it looks like my chroma phase should be left in the middle. And it doesn't look perfect, but it looks like, according to this pattern, I needed to turn my chroma level up a little bit. And so that is what that should look like. So there are many different patterns to choose from here. So let's take a look at what we've got. So we started with SMPTE color bars. That is I think it's called grading and dots. And people often use this kind of a pattern to adjust convergence on vintage CRT monitors and TV sets. There's a gray pattern going from black to white. And all of these have a specific purpose. I actually don't know what most of these are. So I'll just show them to you here. That's an interesting one. That's 30 Hertz. That's a 30 Hertz signal. I possibly, oh my goodness, that's I don't know what that is. That looks like it's flickering at maybe 15 Hertz. I'm not going to be able to show this to you guys. So that looks like, I don't know if that would be a 75 IRE white screen or a 100 IRE white screen. I'd have to have a waveform monitor hooked up to see. That's probably just black burst. And we're back to SMPTE color bars. So there you go. And the next card we're going to hook into has even more patterns than this. So let's take a look at that right now. So we've looked at everything the 2602 TG card has to offer. We are now going to hook into the 1302 BB card. The 1302 BB card has black burst on it as a convenience, but it also has two pattern outputs on it. So I will hook into that now. And hey, look at that. So the first thing you notice, we've got SMPTE color bars and an identification at the bottom. So this is the kind of card that back in the day, if you saw a TV station that was off the air, this is possibly the very hardware that they would use to show the off-air signal. SMPTE color bars and the station identification at the lower right corner. You can see you can put in a fairly long string of text. So I've put in the Maritime Girl here, and I think you can adjust the position of the text too. It doesn't have to be in the lower right corner. And of course this card provides a tone output too that can be adjusted between 400 Hertz and 1 kilohertz. So I will turn this dial right here and flip through the various signals. That's EIA color bars, which I believe predated SMPTE color bars. There are full field color bars. There's the grading and dots again. And you can see the identification remains, whatever pattern you're on. Luckily this has a legend that I can read from. So this is full field red. Split field red, you can see color bars on the upper half there. This one's called window, so I would assume that white square is at 75 or 100 IRE, and then the other side is at 0. That is 30 hertz, a 30 hertz white signal. Once again, I'm not going to be able to show you that. Ah, a safe area. This is a very useful signal. This is the kind of signal that you might run into a video switcher and then key it out and then send it through the video return to your cameras so that your camera operators can see this signal and they can frame up their shots to go with this signal. In the days of analog television, safe area was crucial because a large portion of the video signal would actually be cropped out by your customer's TV. Actually, there's a great example I can tell you about. If you look up the first episode of Sesame Street in 1969 and you look up the segment where Ernie is taking a bath and Bert comes in and says, "Hey, what are you doing, Ernie?" or whatever. I don't know, whatever. You can see the top of Frank Oz's head and his arm in the Bert Muppet. You can actually see a bit of Frank's face and the bottom of his arm. The Bert Muppet does not extend past the bottom of the camera's view. And you can look in the comments of this video and people are in awe. Oh my goodness, you know, TV, the veil has been lifted from the TV magic. We can see Frank Oz's head and part of his arm. But the truth is that when people would have watched that show in 1969, they wouldn't have seen Frank's head or his arm at all. It would have been completely cropped out by the TV set. Because just the nature of analog television, once it goes from the camera to the quadruplex VTR that would have recorded that, then it goes from the VTR to another VTR in the editing process, and then it goes from the master tape played back by a third VTR to the cable system, and then the cable head end will retransmit that signal as well, and the analog signal goes through many steps between when it was output from the camera and when it reaches the viewer's television set. And just the nature of it all is that quite a large portion of the video signal gets cropped out by the time it hits the viewer's television set. We today have the luxury of being able to see Frank Oz's forehead and part of his arm because the tape was very well digitized. And it was digitized using equipment that was able to capture the entire video image, including the parts around the outside that people back in the day would have never seen on their television set. It's very cool. But the implication of that is that when you're shooting a television show, you have to keep that safe area in mind because you never know how much of the picture your viewer is actually going to see. In today's digital high-definition television world, it's not really that crucial. Pretty much all of the picture makes it to the viewer's television sets. However, it's good practice and a good safety measure just to make use of a safe area anyway. I do in my work, especially when you're putting up logos or text or whatever. Never put stuff right next to the bottom. It's just good practice to pretend that your viewer's television set may crop part of the picture out, just like back in the old days. But that's what this is for, and it's very cool that this provides such a signal. So what's our next signal? Okay, we have two different. Okay. So there's two different safe areas here. This one is called safe title. So you should keep your titling in the limits of this safe area. And you can see I've actually violated that because the R and the L of the Maritime Girl are actually outside the right-hand boundary. So you should keep your titles inside this area, and this one's called safe action. So keep your action inside of this area, the subject of your videos and what you want the viewers to see. This is really the true safe area, you know, the limits of what could be cropped out by your viewer's television set. And then this is sort of a courtesy just so you don't have text right up against the edge of the viewer's TV set, especially since text often tends to extend horizontally, and TV sets usually don't have flat boundaries to their pictures, so the edges of text could be cut off. This is, what is this? This is just white. This is probably 100 IRE. And then we have instructions, instructions on how to set the identification. So use the leftmost rotary, rotary selects test signal, left toggle hold plus rotary selects ID pages, right toggle hold plus rotary selects ID variable. So you can store multiple identifications in this. Left toggle hold plus rotary starts, oh yeah, there's a countdown function, which is good if you were taping shows in the studio. You could record a countdown onto your tape, and then when master control plays back that tape later, they would be able to use that countdown to go by when to make the switch to that VTR to begin playing the program. And then there's a couple more here. To program countdown timer, move the toggle switch. So this is the countdown programming page. To program outputs, move the toggle switch, the output programming page. And the ID page programming page. So let's see what we can do here. Aha, okay, so I'm using the toggle switch. I can adjust the countdown. Countdown start, countdown, and pip audio. Let's turn that on. So if I do this, so we've got other stuff. So this necessarily didn't have to be used for putting, oh, there's a fake call sign that I programmed in. This could just be used for internal use rather than something you'd put on air just for source identification, meaning just for identifying, you know, whatever source might be going into a video switcher or router or whatever, just for your own convenience. So I don't know what I'm doing here. Okay, I figured it out. So rotary A means the A position on the rotary dial. If you look right here, for example, right now we're on the C position of the rotary dial. So what you're supposed to do is turn the rotary dial to whatever pattern you want. And I hold the toggle switch left and turn the rotary dial to position A. You can hear the tone stops. And now if I push the toggle switch to the right, and it's left and right and not up and down because it's oriented for the 1302 frame where the cards are sideways. So in my case, if I push the toggle switch down, there you go. There you go, nice little countdown there. And there's probably, yeah, there's a serial port on this thing, so you can probably configure it to, you can probably possibly use simple signaling and wire up like a button that just starts the countdown timer. So that's a nice thing to have. And then if we go to this page, you can set the two outputs, and there's two BNCs for each channel. You can choose whether it's the test signal and the ID, or just the test signal or black burst. You can turn tone on and off and choose which tone. So there you go. And we go to ID pages. This is where you can program an ID. I can do, well, let's do, oops. It's definitely a bit of fumbling required to figure this out. So let's edit this one. We can choose size. Let's make it extra large. Let's give it a border, which just means it strokes the letters with a black border. And then we edit ID, and we can choose what the letters are. So we can go, and I have to use the toggle switch to choose the letters. And then we can set the position. Oh, we've got some corruption here. Yeah, I've observed this before. If you move the text off the screen entirely, it does corrupt it. It just doesn't have any handling for that. You can see it becomes less corrupt once we move it back onto the screen. I'm not sure what this weird character at the end is. But there we go. And now if I exit. Oh, okay. That was just the end character. And now. There. Perfect. My perfect source identification. So there you go, and that's pretty much everything that this card does. So now we're going to move on to the next frame and see what cards are in it. There's a lot of cool stuff that are on the other frame, and I'm just really excited to show you. So let's take a look. All right, so this frame has many more cards in it than the other one. Actually, every slot except for just one has a card in it, and I think all of the cards in this, most if not all the cards in this, are different than the cards we saw in the other unit. For some reason, the power supply has a different model number on this one. This one is called the 6801 PS. In the other one, it's called, I think, the 1302 PS. But they must be the same power supply because these are basically the same product. All the cards are interchangeable. Anyhow, so let's start on the back. And our first card is once again the 1302 GL, the genlock card, because as we said before, this card is imperative to the functioning of all the other cards. So this is a prerequisite. So this frame would have come with probably just this card as a base configuration, and then it was up to you to add all the other cards. So the next three cards are all the same. They are 2602 ES cards. The ES, I don't know what it stands for. It's either electronic still or EEPROM still, because these cards, Leitch marketed them. They called them the PROM slide. These have a still image stored on them. So the signal that comes out of these is just a still image, and the image could be anything you wanted. It's stored in ROM. And we'll look at the cards themselves after I go through them on the back here. So these PROM slides, I did a lot of looking into them because I wanted to see if they were reprogrammable, and it turns out they're not. With the help of my followers on Mastodon, people told me to look and see if a certain pin on the ROM chips was connected, which would indicate programming capability, and it's not connected. So these cards have no programming capability. You can't reprogram the image that's on them. It's stored on there forever. So my guess is either you ordered the card from Leitch with the picture already on it, as in perhaps you sent Leitch a videotape containing the image, and they took that and burned the image onto the card and then sent you the card. Or possibly Leitch made a device that you put the ROMs into and put a video signal into, and then it captured a frame of that video signal and wrote that to the ROMs, which you could then stick in the cards. I don't know. Like I said, there is no information on this stuff at all. But these three cards have three different still images on them. Images that were used by the original owner of these, which we now know who that was. And I will show you these later. And it's pretty cool. Pretty cool bit of history stored on these. The next card is the 1302 SI. The SI stands for Source Identification. This card does kind of what the last card in this one does, where it puts text on top of a video signal. But in the case of this card does not generate the video signal that the text sits on top of. You can see there's a BNC here labeled input. You are supposed to put a video signal into this, and then it superimposes the text on top of the video signal and outputs it through here. And so this is a card that would have been useful, for example, back in the day before video switchers had multi-viewers. Heck, my Sony DFS 700 doesn't have a multi-view output. Before the days of integrated multi-viewers, in your control room you would have multiple, probably 8-inch PVMs all stacked on top of each other, with one of your cameras or VTRs or whatever sources that was going into your video switcher run into it. And you could use cards like this, run the camera output into this card, and then run the output of this card into your multi-view or into your PVM that was part of your multi-view stack. And then you could program the text to say what that source was. Camera 1, camera 2, VTR 1, whatever. So you might have one of these frames just full of these source identification cards for the purpose of just being able to look at all your monitors in your control room and see what source was what, so that when you hit the button on your video switcher, you knew which source you were about to put up. So that's what this does. But this does something else as well. You can see it's got a terminal block on here. One set of terminals says beep, and the other one says TC. That stands for time code. You can put time code in this, generated by something such as the Leitch CSD 5300 clock system driver, and it'll put a clock on the screen below or above or whatever next to your source identification. And so what the original owner of this actually did was, what I'm assuming they did was they used this card in conjunction with color bar signals as their off-air signal, because the original identification programmed into this card was CBAT TV St. John and then the time of day. And the time of day would have come in through the time code input, of course. And that's really cool. So it's like the source identification card in this frame, but with way more capabilities and way cooler. Now, sadly, I did not realize at the time. I decided to just wipe out the card and just erase all the text programmed into it. I figured I'd start from scratch, and that's when I learned, unlike the card that's in this unit, you cannot front panel program this card. It's got a serial port on it because Leitch sold this card with computer software. I think it was a Windows program that you would use with the computer connected to the serial port on the card, and you would program the text in that way. There is no way to program text on this. Now, there actually is a way to program the text on this card. If you hook up a standard terminal to this serial port, you can type letters into it and it'll print them on the screen. But that's all you can do. The Windows software would have sent special, either non-standard ASCII codes or data that's not ASCII codes at all into this port to denote when the time code is supposed to be shown. You can't do that from a standard terminal connected to this or from the front panel of this card. And I stupidly erased the text pages on this card Whereas I should have just modified it, and I could have, for example, replaced the CBAT TV with the Maritime Girl or whatever. And then I could have had a card that said the Maritime Girl and the time of day, which would have been so cool. I can't do that. I can't do that now because I don't have the Windows program. I have looked so hard for whatever software was supposed to be used with this. I've got nothing. Uh, it took me a long time to actually to even discover that Leitch made a software program that you're supposed to use to program this. I found that from an old version of their website. So once again, that's another thing where I'm going to have to try and get in contact with this Imagine Communications and see if they have anything, documentation, programs, whatever, for these frames in general. Or if any of you guys use these back in the day and somehow either have the software program or know if there's some sort of data I can manually send to like program this to display a time code, I would really appreciate that. With that said, we will hook this card up and we'll see what it does. I think it might have a default page that just shows the time of day in like the upper left corner or something. I don't remember. It's been a long time since I played with this. But that's what this card does, and it's too bad that I can't fully make use of it. The next card is the 1302 CC. The CC stands for Code Converter, and this card is quite simple. It takes time code and converts it from one form to another. So there's two types of time code. There's linear time code, or LTC, which is an audio signal. In the video of the Leitch CSD5300, we listened to linear time code. It's a very loud series of very rapid beeps that are digital data, basically denoting the time of day or any time, whatever, it denotes the time code in general. Time code doesn't necessarily have to be the time of day. It could be time code from a VTR, whatever. So that's linear time code. And then there's vertical interval time code, which is exactly what it sounds like. It's digital data stored in the vertical interval of a video signal, just like closed captioning data is. So it's stored in the part of the video signal that you can't see on your television screen. And that was just another way of delivering time code. So this card is able to convert from one to the other. You can feed it linear time code, and then it'll then output vertical interval time code. And it's got a time code out, but I actually don't think this can take vertical interval time code and convert it to linear time code. I think it's unidirectional, and I think the only reason there's a time code out is just for a loop through. So I think because these don't say input or output, so I think it just takes linear time code and converts it to vertical interval time code if you want. And that's just if you need something that takes vertical interval time code but doesn't take linear time code. And then the next two cards are actually cards that we already saw in this unit, the 2602 TG. These are the test pattern cards that outputs color bars and a few other patterns that we just looked at. So that's the cards that are in this thing. Let me flip this back around and we'll pull out the cards and take a look at them. All right, so once again, we can see who the original owner of this was, and we know that this came from CBAT TV, which was the original TV station for CBC New Brunswick. Now this frame's a little older than the other one. This one's from 1994, which tells me that this frame was probably the original frame of cards that CBC New Brunswick had, because CBC New Brunswick didn't exist until 1994. We didn't have a CBC station in New Brunswick until 1994. We had a CBC studio in Fredericton, but that studio uplinked probably via microwave or maybe satellite back to Nova Scotia, which is where the actual CBC stations were. And so back in those days, in the before times, it was just called CBC Maritimes. Well, in 1994, CBC decided to buy CHSJ TV. They were an independent television station run by the New Brunswick Broadcasting Company, which was part of Irving. CBC bought CHSJ TV, recalled it as CBAT TV, and it became CBC New Brunswick, New Brunswick's first CBC station in 1994. But yeah, this is possibly the original frame that the CBC installed at CBAT after they took it over from CHSJ. And so like the still images and stuff that we're going to see on the prom slide cards, they're going to be, I assume, the original standby slides that the station would put up on the air if a technical error occurred, which happens. It still happens sometimes today on TV. You know, technology fails you and something goes awry, and your broadcast dies, and you have to put up a please stand by slide while you get things fixed. We have to do it sometimes. I actually made a video that's stored on our video switcher. It's a please stand by slide with some nice music. And once in a while, maybe a couple of times a year, our playback system fails and I have to switch our master control router to the video switcher, put up that slide and the music until things get fixed. It's just a normal part of the exciting business of broadcast television. And you know, I like watching compilation videos on YouTube, recordings of TV stations that have something go wrong, and once in a while you'll find comments on those videos of people pointing out how old-fashioned the standby slides look. They might have an old logo from the station that the station doesn't otherwise use anymore, and the reason for that is those standby slides, at least back in the day, were generated by equipment just like this, and the slides were written to ROM, and you normally never updated those slides because they were written to ROM. They were there basically permanently. And so, as we said before, a piece of equipment like this is designed to run 24/7, 365 for years or even decades. And sometimes the result of that is any still images that are stored on cards, they keep getting used for years and years and years, and sometimes they become visibly out of date. But it's kind of interesting. And so yeah, we'll see what's stored on these three cards later. So I'll pull one of these cards out. So this is the 2602 ES prom slide, and there's the ultraviolet EPROMs. What kind of chips are these? 24C040. I think these are 4 megabit EPROMs, so these are huge EPROMs. And we have no idea what kind of data is stored on them. As a test once, I took one of these cards and I took one of the ROM chips out, and it still produced a full legible picture. It's just the colors were slightly off. So maybe it was only producing one field. Maybe there's one field of video stored on each chip for a full frame. Not sure. But yeah, there's no programming facilities on this card. What's written there is there to stay, and I have no idea if Leitch sold you a piece of equipment to reprogram a new image, or if you actually had to send the card to Leitch themselves along with a tape of what you wanted the new still image to be. No clue. But you can see these stickers, they actually say 2602 ES and they say CBC on them, which tells me that maybe it was Leitch or some third-party company on behalf of Leitch that you paid for to make one of these cards and put an image on it. So that's going to be my guess. So I'll never be able to stick a new image on one of these, although I have been encouraged by some of my Mastodon followers to read these chips and see if I can find out if the data is something that would be easy to replace, like if it's just data for a bitmap image or something. But the problem is I'm nowhere near smart enough to do that. So this is where I say once again, if you have any knowledge that can help me mystify these things, or any knowledge of how to stick a new image on the card, that would be pretty cool. But there you go. Anyhow, I see some 1993 date codes. I see a 1990 date code. So yeah, it looks like this particular card might have been manufactured in 1993. So here's a prom slide card. Prom, of course, standing for Programmable Read-Only Memory. And here is the source ident card. I suppose I could just stick it right there. 1302 SI source ident card. We've got another Dallas Semiconductor soft micro. 1993 date codes I'm seeing once again. So there's what's on that. We've got a push button switch that's labeled take. And we've got some rotary switches to select the ID number and the ID type, because there are different types of IDs that you can have on this thing. Here's the code converter card. We've got lots of dip switches that set various time code stuff. Got a rotary switch, auto jam. Oh, that's part of the dip switches. I'm not sure what the rotary switch sets. According to this, it sets a plus or minus. Oh, it's a plus or minus offset. Okay. And we got lots of LEDs that show various statuses. What kind of statuses, I don't know. Got another momentary bidirectional toggle switch and push button switch. An FPGA. These must be microcontrollers that have been programmed with stuff. So there's that. Then the other two cards are just the pattern generators, which we've already looked at. So, once again, I'm going to get my monitor hooked up and we will take a look at these cards and see what they can do. All right, I've got you connected to the first prom slide card. Let's power the frame on and see what image is stored on this card. Hey, look at that. Isn't that cool? We've got this nice still image, CBC New Brunswick. And the image itself, I don't know how well it comes across on camera. It's kind of pixelated looking, but the CBC logo and the text all looks very nice resolution to it. So this image was perhaps produced digitally. Maybe the photograph was ingested into a character generator and there's some aliasing going on. Not sure. But yeah, hey, look at that. So that's very cool. I really like this. This is kind of historical because, you know, this is an original image that this very frame would have possibly broadcast at some point. Let's go to the next one. Here's another one. Got someone taking a picture at a beach. Very, very nice. Now I'll show you the third one. The third one's my favorite one, by far. And look at that. How cool is that? A bit different from the other two. That is really, really neat. That is definitely some kind of standby slide that would have been put to air if there was a technical difficulty. It could have also been used, they could have sent this image through a microwave or satellite link, just to let the person on the other end know that they were getting a signal and that a picture of what they needed was going to be coming through soon. But yeah, very, very cool. Love the pretty colors and shapes. That's a kind of a 3D rendering of the CBC logo in various colors in the background. Wow, how cool is that? Very, very, very neat. And I've done frame grabs of all of these, so I have a digitally captured image on my computer now from the images of all these cards. So if down the road, if a card ever fails, or if a ROM ever corrupts because they're UV erasable EPROMs, I have the images captured for posterity, just in case these cards ever fail. But yeah, I really love this particular image. So next we are going to plumb into the source ident card. Now, like I said before, the source ident card does not generate its own image over which to superimpose text. You have to give it your own image. So I've just run color bars into it. And there we go. And I'm going to have to remind myself how to use this. And, oh yeah. Okay, so if I just start twiddling knobs here. Setup menu. Oh yeah, so this can also do a counter. You can set a baud rate for the serial port. Oh, you know what I gotta do? You know what I haven't done? I want to plumb timecode into this thing. Yeah, because I see date and time flashing. So I gotta plumb the CSD 5300 into this. So let me, I've already got a cable coming out of the 5300. I just gotta plug it into this thing. So let me do that right quick, and then maybe we'll have a time and date on this. All right, I connected timecode from the CSD 5300, and there we go. We've got a time and date on the screen, and hey, look at that. It's even got the right date. I'm taping this on February 9th. So, what I would have loved to do, and how this was originally configured, is it had the time in the lower right-hand corner along with the station ID, and it was all generated by this one card. And I foolishly cleared that, thinking it must have been one of the default things, and also thinking that you could program this from the front panel, but you can't. And so I can't really get back what I was hoping to have. I'm just going to roll through the things here. So terminal mode is where you can connect a terminal up to the serial port and type stuff in. So that's what that's one of the ways you can use the serial port. So if I go, what have we got here? So if I turn the other rotary switch, I can choose between numbers. Camera 1, VTR 1. Now where's my date and time? There we go. So software would have been used, the software program that Leitch provided would have been used to program this the way it originally was, with the call sign and the time in the lower right hand corner. And now I can't get that back. And when you go into terminal mode, you can, I forget how to get there now, but you could see that there were weird special characters that were used to denote where the time and date are supposed to go. And I tried sending non-standard, like I tried sending extended ASCII codes just to see if one of those was the time and date. but I never could get the time and date to print out by typing into a terminal connected to the serial port. And you can edit pages, like I could edit this page with a terminal and type other stuff in the terminal, but it's permanently in overwrite mode. There's no way to insert characters and shift stuff over. I can type and it just overwrites the special characters that make it print the time and date. So I'm just kind of screwed until if I ever get that software. But that's what this card is capable of. And that's, I think, the last card that I'm going to show, because the other cards are the code converter, which there's really nothing to show, nothing interesting at least. And the two cards after that are just the pattern generators. So there we go. And that's the scoop on the Leitch SPG-2602N sync pulse generator and FR-2602 multifunction frames. You don't gotta hear it from me. These are pretty cool devices and they provide a lot of functionality, and hopefully today I've been able to adequately show you the bulk of that functionality. These are really cool. I like having these in my television rack. They're fun to have. It's fun to have a source of color bars and be able to stick my name on it. And there's a little bit of history too with the images that still live on these prom slide cards. And I've actually made genuine use of these because I specifically use them in conjunction with another device that we're going to look at in a future video, and that's a waveform monitor. And I actually have a few different waveform and vector monitors, and eventually we will have a look at all of those as well. But yeah, these are super useful for calibrating those waveform monitors, and then I can use the waveform monitors to verify the performance of VTRs and the recordings on tapes when I'm digitizing tapes. Just recently I digitized a Betacam tape, and the tape was recorded poorly and the video level was up way too high, and I was able to verify that because the tape had color bars on it, and I was able to compare the color bars recorded on the tape with the color bars generated by these guys, and I was able to see that the video level on the tape was way too high, and I was able to lower that so that I could make a proper, good-looking transfer of the tape. So these are very useful as well, not to mention the ability to genlock all of the other stuff that I've got in my rack to a single source. VTRs, the video switcher, and stuff like that. So yeah, I really like having these. I'm glad I was able to find them. Glad I was able to fix their power supplies, because both of them had power supplies with bad capacitors in them. But if you want one of these, they're not too expensive. There's a ton of them on eBay actually, and there's also a lot of the older versions of these that have blue faceplates, like the CSD 5300 has. So you can find an awful lot of these on eBay. Some of them I find they just have a black burst card in them. Some of them have color bar generators, and then some of them have some other fancier cards that we haven't looked at here that I have no idea what they do. And the prices range wildly. I saw one on eBay for 15 bucks and 40 bucks shipping. I saw others that were 200 bucks. And for goodness sakes, don't pay that much for one of these, especially if it hasn't been fully tested. And even if it has been tested, because the power supplies on these can and almost certainly will fail, be ready to have to recap them. And in the case of these ones, I brought them home and they both worked for about a week, and then the power supplies failed. So they might work while the seller has it taking photos of the output and stuff, but then when you get it, it could be dead. So whatever you choose to pay for one of these, if you get one, be ready for it. And then also recall that there's a smaller version that's just half the height, the SPG-2602N. So if you only want or need the capacity for 4 cards, you can go for one of those as well. But that's it. Thank you so much for watching. I really do hope you enjoyed having a look at another piece of the vintage broadcast television puzzle. And thank you also for your patience. I know by the time I get this video out, I think it's going to be about a month and a half, if not 2 months, since I made my last video. It's just things have been busy. Work has been busy, the good kind of busy, and life has been busy. Also, mostly the good kind of busy. And then also with just the state of everything going on in the world right now, if you live on this continent, it's kind of been nice just to step back from the internet. I haven't been on the internet that much. I've just been enjoying kind of doing my own thing at the workbench and not having to worry about making videos and getting video content out. So thank you for your patience. Also, thank you to everyone who chooses to support me via Patreon. It's thanks to you guys that I can go on DigiKey and send in a $50 capacitor order to repair the power supplies in these and not have to really worry about the money, because I am running a pretty thin budget these days. And I have a feeling that with the things going on right now, again, in this part of the world, the budget could get thinner. So I really appreciate everybody who chooses to support me with their dollar or more. That lets me spend the money needed to repair stuff like this and also procure new cool stuff that I can show you on video. And everybody who chooses to support me just by watching, thank you to you as well. I really appreciate it. So that's it, and I will see you in the next video. Okay, turn.
City of Calais. Keys to Life Tabernacle. I want to go there. They apparently have the keys to life. Florence. Florence.
I can't help myself sometimes.